Thanks, Angelique. Hi, everyone. I'm Prab Singh, and I lead a few core areas of the product at ThousandEyes. As Angelique pointed out, the state of the cloud is constantly changing. And as our largest providers continue to prioritize and make infrastructure investments, it really impacts how our organizations and their customers access these services on the cloud providers. I was fortunate to be able to join ThousandEyes over 7 years ago and have had the opportunity to work with customers to help them manage and de-risk their cloud migration projects. And so I'm really excited today to share some real examples of how our customers measure cloud performance using ThousandEyes. The first example I want to share is essentially around a rideshare company. So in this example, you can see a rideshare company host core parts of their web application in Google Cloud. And imagine booking a ride where you're on a mobile app and the core mobile application being served from Google Cloud. And they've deployed their enterprise agents across various parts of GCP where they've got the core web application deployed. You can see also in the table view, very latency that's going from different parts of Google Cloud into Ashburn, where they have a core payment service that's still on-premise. And this payment service is critical to ensuring that payments are made seamlessly across the Google core mobile app. And depending upon which region of the Google Cloud you're serving this content from, the payment service can be anywhere from 274 milliseconds all the way down to single millisecond. What's also interesting is when you look at the path visualization, we can see their connectivity from Google Cloud all the way to their on-premise payment service. We can actually sort the agents by network and location, different parts of the Google environment where the agents are hosted. So we can see agents in the Omaha, Sao Paulo region, Belgium, Australia, Japan, etc., that are all connecting to this payment service within the on-premise network. The other really interesting point I want to share is being able to see these red links that are going across a link local address, which belongs to a cloud router that connects to their on-premise network. And if we zoom into this agent environment, we can actually see in the agent details the presence of essentially a VPN tunnel through the TCP maximum segment size of the path MTU being smaller than what you typically expect. A typical packet with no VPN tunnels present would have a path MTU of 1500 bytes and TCP maximum segment size of 1460 bytes. And so you're seeing the presence of a tunnel, and the red links are effectively showing you links with high latency that are connecting from the South America East 1 region to this link local address. And eventually, they connect you through this address within the rideshare's own network, and then through their private network on down to the payment service that's being accessed. Now, what's interesting is they see an increase in payment verification failures through their core web application. And when that happens, they're able to very quickly go to that time period and see where the core web applications are failing, and then being able to visualize where the problems are occurring across Google Cloud, the partner interconnect that's connecting them through to the on-premise data center, and then the on-prem network that's serving the payment gateways. And during the time of high loss events, when the payment failures happen, you can see on the left-hand side that most of that loss is coming through two specific GCP regions in the United Kingdom, as well as Sao Paulo, Brazil, while all the other GCP regions across Singapore and others are seeing zero loss because of the green color on the agents. And if we simply focus on this particular set of agents and hide all other agents as part of this network, we can now see where the loss specifically is coming from. As we saw earlier, this particular US region in Europe, GCP region in Europe, is connecting through a link local address that connects them through the rideshare's on-prem network or partner interconnect, then connects them through the partner interconnect, and then is now seeing loss, or high amounts of loss, across the last link that connects them to the payment infrastructure. And the broader point here being, as companies continue to migrate to the cloud, it's a longer migration across multi-year that requires parts of their web application stack or application stack to be hosted in the cloud, while others are still hosted on-prem. And being able to understand how the cloud network, the partner interconnect, or even internet VPNs, and then on-prem infrastructure are impacting end-to-end experience for users is critical to understanding your overall cloud performance. Now, let's take a look at another example where cloud dependencies are invisible, but they have a great impact in how we consume services. Imagine you're working from home and you're trying to join a meeting and you're unable to join that meeting. And you open up a browser, you go to google.com and you try to verify you have internet access. And a lot of the times, if you have internet access and you have no Wi-Fi issues that you see locally, you assume that you're having a problem with the collaboration app that you're trying to join a meeting with. But in IT ops, it's critical to understand how your applications, specifically your SaaS applications, are being delivered, even though they're being consumed as a service. A lot of the times what we've seen is your software as a service application is hosted on an internet infrastructure as a service provider that's impacted by regional internet failure. And so that's exactly what we saw in a famous event last year. Now, if we look at this example, we can see this application start to have availability drops from some locations in Europe and Asia. And when we see this, you can see locations across India, in Dubai, as well as Ireland and New Zealand start to see availability drops. Not only were they seeing availability drops, but you saw higher than normal response times, even when responses were being received from these agents that are measuring availability of this application. In some cases, the response time was almost 3 to 4x normal response times, saying that even though I have connectivity, it's much slower than usual. When we look at the network overview, we start to see that this is directly correlated with network-based packet loss that's impacting availability to this application. When we look at the table view, we can start to see a detailed view of all the locations that are seeing loss. Specifically, if I now go into the path visualization, this is where things get really interesting, because now I can see where the loss is originating. And as I scroll through the path visualization graph, I can see that the loss is happening in locations somewhere in Texas, in some unknown locations in the US, as well as other locations that I'm seeing some red nodes. To more clearly understand what's happening, let's take a look at a specific example. We know there was problems in Auckland, New Zealand, so let's take a look at what might be happening. What we're seeing is during the time of the problem, this location, a user, let's say, accessing this collaboration app from New Zealand, is typically served from a local Auckland, New Zealand ISP, going through Telstra Clear, which is a local ISP, that then takes them through Vodafone, and then across kind of the Vodafone private backbone into what appears to be India, and then across another kind of backbone going across to US, which is where all traffic was being terminated. Which is really interesting because if we now go back in time and observe what the steady state of this application experience looks like, you're still going through the local ISPs in Auckland, New Zealand, but instead of going through India, you're going through the Trans-Pacific cable across New Zealand all the way to the US and the west coast of the US, and then eventually to Dallas, and then to Ashburn, where this particular collab app is hosted, which happens to be hosted in Amazon. And what's interesting is we can even go deeper and look at the BGP views to try to understand why Amazon, in this case, was having an issue that had connectivity problems to this collaboration app. If we go to the BGP view, we now see a look into how looking glasses that are all across the internet are seeing BGP connectivity to Amazon's AS. In this case, that's in Ashburn, that's hosting this app. And we see a direct correlation, not just in loss, but also in BGP path changes at the exact same time that show us that there was BGP activity that impacted the way Amazon was able to serve traffic to their customers. Again, if we simply look at one of the specific monitors and try to observe what happened, we can see that during steady state, this monitor had connectivity to this private to this local AS that connected through GTT, which is a pretty large ISP, that connects you then directly into Amazon. It's a transit AS that takes you into the final AS that served this traffic. But during the issue, we saw effectively route changes or path changes that affected the way traffic was served. If we look at the detailed path changes, we can actually see the AS path changes with exact timestamps. And what we see is Bharti Airtel, which we saw earlier, essentially become part of the path of how traffic was being accessed from different parts of the world. And Airtel, in this case, effectively became a man in the middle or an ISP that subsumed routes from all parts of the world where it wasn't able to serve traffic to Amazon, leading to a black hole that we sometimes see happen on the internet. And this is how effectively being able to understand how a SaaS application that you rely upon that's hosted on an IaaS provider that's suffering from a regional internet outage is truly impacting how your end users consume applications. And understanding these invisible dependencies where we may not necessarily know exist are critical to understanding your cloud performance.